Hello, geometry students. Short and sweet today. Lesson 4-6 SSS theorem, that's side, side, side. You use it just the way you use the side, angle, side, and the angle, side, angle. So theorem 11, if the three sides of one triangle are equal to the three sides of another triangle, the triangles are congruent. So here's an example of how you would see it in a proof. Okay, and another chance for us to practice the triangle congruence proof. We're told that in this particular figure, given AB equals AD, C is the midpoint of BD. Prove triangle ABC is congruent to triangle ADC. Alright, now let's review how you do these proofs. First, you have to sketch that figure on your paper. You have to write down your given. You have to write down your proof statement. You have to make the two columns. And so AB equals AD. This is how we indicate that. Single tick mark means those two side lengths are equal to each other. C is the midpoint of BD. Alright, you got to think about what that means. Notice it does not say that we've got any equalities coming out of that, but we know that if C is the midpoint of BD, that these two sides will be equal to each other. These BC will equal CD. But again, in the first given statement we had an equals sign. We don't have one in the second given statement, so we have to follow this given statement up with an equation that says something's equal to something else. Alright, so now you know also that we're supposed to prove triangle ABC is congruent to triangle ADC. That's the two smaller triangles that are made here. So that's this one and this one. Alright. And they happen to share the side AC. So since they share the side AC, we'll be able to use that in each of those two triangles. Alright, so that kind of maps it out for me. I got side, side, side here. Alright, so here it is, how you would do this. Start with a given statement, AB equals AD. There you got one of your equality statements, and it's a side. Then next we're going to talk about the C being the midpoint. And so C is the midpoint of BD. That's given. Okay, now I have to make the explicit statement that what is the result of that C being the midpoint. That means that BC equals CD, and that's because the midpoint of a line segment divides it into two equal segments. Right, and that is a second equality statement, and that's a side. And I think you know what the last one is, and that is that we've got side that is equal to itself. Remember, that's reflexive property. It's like reflection in a mirror. AC equals CA, and that's by reflexive property. Okay, so there's our third equality statement. It's another side. So now, instead of just having two ways to decide how you're going to show triangles congruent to each other, you have three ways. You have ASA, you have SAS, and now you have SSS as well. So now we can say that the triangles are congruent by SSS. And the proof for the SSS theorem in your book is a little bit complicated. We might talk about it just a minute, but not at this time. So at some point we might look at that so you get a little bit of an idea of how more complicated proof works as well. But this is the side, side, side theorem. It's a new one, and you are now free to use it.